time on a Sunday morning that you have spared to attend this session. And I hope you would really enjoy and understand some key takeaways of big data and Hadoop during the course of this presentation. So let's move on. This whole webinar has been organized into 3 parts to make it very simple and straight so that you get used to it. I understand some of the folks who are joining on this call may not be very familiar with the terminology that we're using. So what we did is we have broken down into 3 parts. In the first part, we would see some of the use cases in the market and also how market has been evolving in adopting analytics and big data. In the second part, we would see, I think most of us would be interested to know how the job market and what are the various job opportunities available for big data and analytics and its technology stack. And we also tell you what are the different companies who are right now are doing very well in the market for these technology stacks. And part 3 would be mostly on the way the big data has been organized. We would understand what are the different attributes and characteristics of the big data. And we'll also understand one of the primary technology stack from Hadoop, Apache Hadoop, which is actually meant for solving these big data problems, or which is widely used across industry for implementing a lot of the other solutions. So these are the 3 parts we would be focusing today in this webinar. Just a brief intro about me. I'm an architect and I work on solutions which very widely used many of the big data technologies, and we use these technologies for getting greater insights into the data that we have today, and we also use these technologies which actually helps us in deriving a lot of business decisions. Even during the course of this presentation, you will be seeing that the use cases that we'll be presenting today and how the big data is used and how the analytics on top of that enables a better decision-making capabilities. I also have a domain expertise on revenue management, so I primarily work on financial data. I'm a very ardent and passionate learner of analytics and its associated technologies. All right, so let's get started today. Before we move on, as I said, we will be looking at some of the use cases to make yourself a little used to or accustomed to what about the problem statements that we have today, and how we are defining a big data, and further how the Hadoop and its associated technologies are helping us to solve those problems. So assume that I have given you a movie. The first sequel of this movie is around 1.5 GB of size, and I ask you to watch the movie in length and breadth and answer a few of the questions, like one which I have posted on this slide. I would like to know that what was the storyline that you understood from this movie, what was the main lead, how he found his lady love, and what was the ultimate scene that resulted into the climax of the scene. So I know fairly most of us are aware that a 1.5 GB of movie would span up to an hour or 2 hours, and it would take an handsome close to 2 hours for us to go through the movie to understand it in length and breadth and answer these questions. And what if I ask that there are 10 more such sequels and you have to watch them and tell me all the answers that we have listed in this slide? So it may take a day for you to do it on your own. So we're saying that you just have to do it on your own on a manual way. You just have to go through the entire movie sets and understand the storylines, understand the plot of the story, and to draw an insight. So bottom line is, what I was trying to give you is a fairly simple data set, and I'm trying to draw some insights. So these 3 are the insights which I was trying to ask you to do through it. So if you want to do it through your naked eye or just a manual process, it takes a considerable amount of time to draw all these kind of insights. Now, let's say if I give you a library of movie databases and I just ask you that this is the data set that we have got. This is the database which spans from 1940 to, let's say, to today. And we want to understand some more insights from this data set. Those insights could be what was the best action movie, or what was the worst thriller movie, or what was the most popular fiction movie that was available from 1940 or in the era of 1970, or the movie that has generated most revenues, or the movie that got most Oscar nominations. So, and now if I ask you to write a piece of software, I'm sure you would be able to do it, and you will be able to draw some more insights from it. But the key thing for us is how much time this software would take for us to draw these insights, and how much scalable this software would be to really draw all these kind of questions and answers that we are talking about today. So the assumption would be it should be a big, huge voluminous database, and then the software that you want to write should also have an attribute of taking care about how much of volume it can actually store, and store it in intermediate stages and persist it towards the end. Okay, so that's a big problem that we are dealing with today. So we have databases which spans across millions of rows, trillions of rows, and we obviously want to draw many insights. The insights could be of various needs, to make various business decisions, or to make the underlying theme understand very well. Now, I think most of us are very familiar with sports. How often we have seen in sports that the statistics that's been available today. If you see any team in the world, you name it cricket, you name it soccer, they have certain statisticians always accompanying the team. They travel through them across the globe. Okay, there were some chats. Okay, so these statisticians' job is to understand a data which is relevant to the team, which is relevant to a player, and it is relevant to your opponent that you're going to face in your next matches. So there's a lot of such data that they use to draw an insight. So the insight now we're talking about is how a player is performing over a period of time, how a team is performing based on external conditions. Because if these conditions, it's obvious that most of these conditions will be unfamiliar to the teams. So they would like to see or predict the team's performance on the external conditions, like the weather, the way they've been played on, or past record of the team on certain grounds or certain playgrounds. So those kind of the predictions we would require to draw an insight from these data sets that we are available to the statisticians of the team. And how often you need to focus on certain individual players to make them deliver the goods so that you have an impact on the final outcome of the game. And the last one, obviously, that's what most of the teams do. They do these statistics to understand your opponent's strategies, plans, their player moves, reflexes, you name it. So these are the kind of another use case which we see today, where analytics has been making strides, and it's been very widely used. All right, very interesting stats. I think most of us would be very unfamiliar, or would have a question that how come these big data analytics finds a use case in elections or politics. But it's very unknown. It was very widely known in some of the analytics forums and communities that in 2012, when we all know that Obama has tasted the victory, what he has done was he has employed a team of statisticians whose job was to use these data sets pertaining to certain states, certain communities, certain group of people who have a kind of liking or disliking towards policies or government and other things. So their job was to do a data analytics, and so that they can do a comprehensive campaign planning based on you cannot do a very umbrella or template kind of campaign planning for a state X, and you implement the same for the state Y. So they were using this data insights, and once you know what's your data is all about and how your data looks like, and what are the different attributes associated with certain constituencies or certain group of people, they also used to target the advertisements on social media and in print media based on these statistics that are available. And the most important thing what they have really tried to understand is the people's behavior, maybe on your social media feeds, or the way they were participating in the debates, the responses that's been given. So there was a lot of analytics done on these data sets. And we all know in history now that Obama has really used it to a very good extent, and he was successful in major fronts. So this was another use case where you see, there's a lot of analytics being used in large volumes of data. So these are the three use cases which I wanted to present to you and to make you familiar and to see how the big data and its associated technologies and analytics are really helping different kind of solutions or businesses or even individuals to achieve better decision-making capabilities. Right. We all would be interested to know, I mean, yeah, that's what we all are here for, to make some career insights on the big data platform or on the big data technologies and analytics. So there's certainly a lot of demand these days for analytics, because there is a gap in skill and available resources that we have right now in the market. Each company is very keen on gaining a momentum and implementing analytical solutions to their businesses and to their solutions. So there is quite a demand, and I know, as far as I understood, the American US markets, even there, the hourly billings can range up to $80 to $120. So there is a demand everywhere. You name it, in Asian markets or American markets, the job markets really need. So what organizations are right now doing is they understand what's the need. Unlike the past where there are only few companies like Google, Target, who used to find some use cases in their solutions and draw an insight from these solutions. But now each organization feels that to stay competitive in market and to understand their customer preferences, consumer preferences, their competitor preferences, their other business strategies, they are actually prioritizing all these analytics into their mainline solutions. And since it's actually in demand, you can express good paychecks as well. Now, why you would always feel that why there is such a sudden need for this big data analytics, and why the majority of companies are really trying to find people or skilled resources in these areas is, unlike in the past where most of our data used to remain as structured. I think most of us are coming from a relational world, so we know that our data, how it's defined, what is the schema for it, what is an entity relationship that we have in the data. So now, if you see with the advent of social media, you have 3G devices, you have 4G devices, you have RSS feeds, you have a lot of news feeds coming in, you have people expressing their opinions on forums, public forums. So there is a lot of data which we got today, which is not like a conventional relational database, and which could be an unstructured and semi-structured. We would understand what these structured and semi-structured data would be in the next few slides. But imagine now we have got three varieties of data where you really don't know how they are interlinked. So how do you actually conquer these problems? I mean, you really need to approach it in a different way. So there is a data which is growing in leaps and bounds. So there is data analytics which is used everywhere, and there's a lot of use cases which are available in the market on these big data analytics. And I'm telling you, I mean, with my experience, that there are companies who have actually gained a lot of business based on these analytical skills. I can tell you one example wherein the General Motors, which is very famous in American and European markets, so it has actually optimized its cost by millions of dollars by introducing analytics. What they did is they actually did a lot of analytics on the parts that they introduced with each model or a type of variant that they introduced to the consumers. And they found out that some percentage of these parts are really not being very widely used, and they can actually optimize or cut short these products from the next product line delivery. So they did these analytics based on user preferences and user usages, and how often a user uses these extra additional features that deliver with each product. So likewise, there are many other companies who actually are understanding, and they're trying to get these analytics into their main product line. All right, so what are the career opportunities we have got? It has got different kind of roles that we are looking at. We know as a business consultant, these guys really help to provide analytical insights into what a product profile could be in their next other markets, or they're introducing a new product profile or new product line into a market. How would they do it? I mean, earlier it used to be just based on your historical or operational data, and you draw some insight and you deliver it. But now it's a very competitive market. So these business consultants do a data analytics, and they predict their product profile, a product line, or a business strategy into new markets. And there is an analytical architects. What they do is they design your end-to-end solution, or they design your basic framework, how you implement or introduce this analytical platform and technologies into your main product line. And there are these guys like data engineers who work on your platform to process your data, to model it, to standardize it, So these data engineers are also in quite demand because these are the guys who actually help you in processing your data. And there's a solution architect who really understands your kind of solution or a business profile that you have got in the market. So they also try to align with what we have got with data analytics. And data analyst is a very common term because they are domain experts, and business intelligence and analytics consultants also are in huge demand right these days. So the bottom line, there is a very good market available today, and there is a gap between the skills that we have and what is actually offering in the market. So there are opportunities available. All we have to do is make ourselves skilled, trained, and get into these markets and to explore the new job skills. And I'm telling you, next few years, maybe by 2020, there would be a lot of data that each organization would be mining through, and their traditional tools like the SAP tools or your data warehouse tools may not be sufficient. The business objects that they use may not be actually really sufficient enough to do, or not may not be capable to provide all these analytical insights on these data sets. So the market is good. Hopefully, if you all can learn these skills, and you might be able to explore a lot of career opportunities. Now, the big question: how do I move into this big data world? It's little. We need to, as with any other new technologies that we get in the market, the approach is actually a two-dimensional approach, which I would say. So unlike if you're from a functional programming or an object-oriented programming or from a data warehouse background, you just have to think a little different here, because the data is a little huge. And as I said in my previous slides, the data is quite distinct and varied, and you cannot actually predict it. So you need to join a course which actually teaches you how to understand a big data and apply the analytical skills on it, or apply the analytical analogies on it. So in Techcanvass, we also give you a very comprehensive set of projects, real-time projects, and these assignments are very comprehensive. So if you to make yourself hands-on and familiar with different approaches that we do, or with different techniques we have got to solve big data problems. And unlike in the past, maybe around 2008-9, it used to be a very closed communities because there were very less use cases. But now, as I said in my previous slides, there are a lot of companies which are using big data and analytics. So that actually helped evolving many open source communities which you can subscribe. The benefit and advantage with these communities is you will really know each problem has its own way or an approach to solve these problems. So you would understand how a problem X has been solved using a different analytical technique, or how you actually conquer these problems, and you can even expose your problems as well. To stay tuned on all these trends, you can obviously subscribe to these communities. Since like you, there are most of other folks who are also trying to learn these skills and get themselves acquainted with these kind of technologies. So if you do a certification, maybe like the one from Cloudera, you have one, and there are a few others available in the market, that may give you a little upper hand, but don't worry, it just gives you an upper hand over others. But if your fundamentals are clear, and if you thoroughly understood how a big data could be organized, processed, and analyzed in these platforms, that could also help you to gain some momentum. And obviously, yes, you have to put all this stuff in your resume. And I'm sure if some of your companies that you work for today may also be looking towards moving into the big data and analytics. So you can check with your folks as well that there are any jobs available with your internal organizations. But even then, as I said, the outside market is really, really good. So you have a lot of opportunities available. So go ahead, guys, and make most of it. So there are a lot of use cases. There are a lot of companies with a different product profile, different solutions, solution offerings. They all are into analytics, and they need people. So they need people who are skilled enough in these kind of technologies. So, but there may be little variations in your role. Like for example, a big data engineer would have more opportunities because that's where you need more people to solve these softwares and write these softwares. We can process the data. So there are other skills which would be a little higher than like a business consultant or a data analyst, which would require a domain expertise. But nevertheless, these are the companies who are actually doing a lot of hiring. The retails like Target, Walmarts. I know some of the Indian companies are also recently started doing these. Retail companies are doing the analytics. Telecos, yes, they need big data analytics because with the advent of 3G and 4G, there's a lot of data in mobile switching center or a tower which actually generates the data and about a device movement or any other call drop rates or how often a data is being used. So there are telecom companies which also wants to do a big data analytics on their mobile switching center usage or a BTS or any other things. Financial services, yes, it's been, I would say this was one of the first to adopt the big data analytics. You have a lot of financial services in US markets like Fidelity, Franklin, you have many. I mean, they all are doing analytics right now. The healthcare is now gaining momentum. I think it is second or third largest consumer of data and analytics platforms. The reason being, in American markets, you have or the Western markets where you have a lot of data which goes through insurance, and you have a lot of data which is actually organized into WHO forums. So healthcare industry is also be one of the major, major companies which may require these professionals. Yeah, and e-commerce, we all know the Flipkarts, the Amazons, they all do, and I think most of us would have experienced the kind of analytics they do. We log into their page, they just show up our preferences based on our past search criteria. And social media, yeah, I mean, this is just a gold mine. You've got, there's everything available on social media these days. You tweet, you post a feed, so there's a lot of data. So there are companies who wants to do a sentiment analysis of certain group of people or certain consumers who are interested in their product profile. So there's one such use case which is also available. So for that you need a social media analytics on it to do a sentiment analytics. The last one, it sounds a little interesting. There are startups also, though traditionally the market have seen that we have companies with a good product profile or which have a historical data which spans across decades. But there are now startups which are also coming up. The job of these startups is to analyze or help the new companies adopting big data analytics. So not every use case is successful, to be very honest. Not every company was, there are certain failures also where people really didn't understood how to implement big data into their solutions or big data analytics. So these startups, they act as consultants. What they do is they do a sampling on the data sets. They provide external consultancy on how they can approach these problems, how they can introduce the analytics platform, the analytics statistical models that we have got. So these companies are also hiring very good. Though there will be a little apprehensions in our mind that how far they can succeed, but there are good startups as well in American markets which are doing fairly good as well. Right, now we have seen the use cases, how the job market is. Now let's actually get into the actual stuff and understand in next few slides, how do you actually define a big data? What are the different characteristics and attributes of a big data? And what are the different sources and how and why they are producing these kind of data sets? And how do you tame this big data? Because when I say big, it's really big. It's not the order of many bytes. So how do you handle such kind of big data? And what are the conventional and non-conventional approaches that we see in the market? How different businesses have adopted or implemented these techniques to analyze or draw insights from this big data. So these are the next few things we'll be learning in next few slides. I think there is a lot of data growth in last few years. The reason why I say it's huge because with the advent of 3G technologies, 4G is coming in our way, and social medias like Facebook, Twitter, there's everything. I mean, there's a lot of other web applications available, and there are these servers which are dumping huge logs, like Google servers, which keeps track of a user pattern to do a page ranking. For example, when you visit a certain keyword in Google, what it does is it maintains a page rank of that particular website or a keyword, how often that word has been searched, and based on the popularity of that keyword search, it keeps a track of the rank, and keeps a ranking, and it maintains a ranking of this of those pages. So there is a data explosion, like the way we have witnessed the industry revolution, where we have seen industry how it has grown from a coal-based or a normal hydraulic-based systems to more modern systems it has acquired, and how agriculture has evolved over many years. Now, this is the era where data is revolutionizing, and there is a data which is growing everywhere. So these are the factors which are actually contributing for the growth. And as I said in the slide, there is 90% of the data in the world which was created in the last 2 years. That's amazing, actually, because you have been seeing a very exponential growth, and that growth, which actually on a rough estimate, it's compounded around 40% at an annual rate. Now imagine there is a data which is 10 zettabytes. So I, just for your reference, have added the hierarchy of how a zettabyte would look like. For instance, 1 MB would be of these 1024 KBs, and 1 MB, 1 GB would be, if you are aware about 1 GB, a terabyte would be a 1024 GBs, and a petabyte would be a 1024 terabytes, and an exabyte would be a 1024 petabyte, and 1 zettabyte would be a 1024 exabyte. So you see, this is the volume of data we are talking today, and this would go by almost 40 times or 4 times of what we have seen today by 2020. So there's an enormous data, a massive volume of data which is lying in these servers, or in social media, or in logs, or in feeds, or in relational databases also as well. So the kind of data explosion we are witnessing today is quite tremendous, and there is no stopping to it, and it's going to grow more and more. I'm sure above 4G there would be more such technologies which would enable faster speeds or higher rates, or higher data transfer rates. In addition to that, there is also these web applications, or the sites or the URLs which we have seen today. They would also enable or contribute towards this data growth. So now we're still trying to understand how big the data is. There are data sets which are lying everywhere. So data is nothing new today. Data has been always there from decades. So, but what is this big data is all about? So if you are very familiar from your relational world, or if you are a business analyst, or a solution executive, you would always know that always the data was in flat files, or in some databases, or in some images, in blobs, which may be in the tune of few GBs. Now this data is actually growing in the order of petabytes, 10 to the power of 12 times of your ordinary file sizes. So we are getting this data from everywhere. So unlike in the past, where your source of data used to remain constant, where we have only, let's say, if there was a website which actually takes the user inputs and persists it into your base. But now the scenario has changed. Now you can even expose your apps to the mobile devices. You can even get the data from your social media feeds. I'm sure if you're aware, there are a lot of commercial companies which now they do their business on Facebook. If you have seen their advertisements, they also say that Facebook.com/ their company name, because these are the very common platforms available to even promote and to do a business. So you can even expect your data source for a business from a social media. So the data obviously is going to grow. So and it's good for your organization, if it's good for your business, because that tells you that your product profile is growing and you are more such users who are trying to buy your product. But the challenge would be the more data you're getting right now. So even today, if you visit any website, any news website, there are a lot of feeds on the bottom of the page which are given from different other news websites, or other blogs. Because such is the technology. Now the technology has evolved so well that now it actually mixes up your data with the data that is available in the internet. So that's the kind of data. But let's actually try to define, or we've understood, in previous slides, how the data would look like, how the big data is, what are the different sources available, what is the volume of data we are talking about. But to clearly define in some terms of words, if you want to say how do you really say what are the attributes of a big data? So these are the attributes which we are talking about, which we have actually spoken about in previous slides. We said a data which is massive in volume, which can be in petabytes and can scale up to zettabytes, and velocity. So interestingly, until in the past, we never spoke about, or we never thought how often this data gets generated. Uh, Let me give you an example of a soccer match where, as we have seen in our second slide, one of the use case in big data analytics is sports. So in a soccer match, when a player who is moving, let's say a forward or defender or a midfielder, so there is a data which he generates based on his moves. So every second, the reflexes he makes, the moves he makes, and the kind of strategies the player adopts. So that it generates a lot of data. Even any sport, or you take any other event, there is a velocity associated with this data. So there is at a very constant rate which data gets generated. So that's why it's huge in volume. So if it's just a volume, and if it's being generated in batch mode or in a static mode, we wouldn't be very surprised to it. But there is a velocity associated to it. So that is one aspect which also defines the big data. And the third one, the variety. Yes, I mean, the data, as I said, could be in any form. It can be from your social media feeds, it can be from your relational databases, it can be from a flat file, and which you got as a feedback from your consumer. So there is a lot of variety associated to it. You cannot actually say that, I only work on certain characteristics of your data. So these are called 3 V's of big data: volume, velocity, and variety. But I also added 3 more additional characteristics, which are called structured, unstructured, and semi-structured. Because if you just assume that you're any of these or mix of both, it just remains structured, I think we have a very fairly simple problem to solve with. If you assume that your data is always structured, organized, and you assume that there is certain schema or entity relationship being associated to it, so I think we didn't really need to have to worry about this data. But there is a data which is unstructured and semi-structured also. So unstructured would be, the way you're reading certain news feeds and you don't know what is the defined pattern to it. Like if you're from a relational world, you would say that I have a primary key. I know how this primary key is related to a foreign key. I know what is the entity relationship between these two tables, between the two entities of these two tables. But when you're seeing a flat data, you really say that it's unstructured. So there should be a different approach to solve this problem. And ironically, there is also a semi-structured data. One example could be the log messages that we see. I think most of us would be familiar how a log message looks like. There is a header and a body. The header always contains a fixed set of information which says that at what timestamp or a date on which this log was generated, what was your process ID, what was the instance of this piece of code which triggered this message, and blah, blah, blah. So there are fixed components to it. But when it comes to body of your log message, you really don't know what it can contain. It can contain just plain stack trace. It can contain, certain logger information that you're putting in. So you can also expect such kind of semi-structured data in big data world. So to summarize, there are 3 characteristics, primarily 3 V's: volume, variety, and volume, velocity, and variety, and any or all of them, like structured, unstructured, or semi-structured. So this qualifies the data to be called as big data. So I know the term big is a little misleading. Don't assume that, if it's just massive in volume, it can be big data, but it should be generating at a constant rate, and it should be varied. Otherwise, there is no need for going through the Hadoop world to solve this problem. So that's what these consultants that do. They actually first try to characterize your data based on these attributes, and then they try to suggest you what should be your approach in solving or getting an insight from this data. Because remember, there's always a lot of cost involved when you're doing this big data. When I say cost, it's not the infrastructure investment, it is also the resource investment, the software investment, and also you have to design, when you're trying to derive a statistical model out of these data sets. So it needs a lot of time to train your algorithms. So there's a lot of effort. There's cost involved in implementing the big data analytics. So first thing first, you always characterize your data, how your data looks like, and what category it falls into it. and then you start implementing your big data and Hadoop technologies to gain the analytical insights to it. So there are a lot of input sources. We have been talking all the while. There are different social media feeds. There is share markets, your financial world, retail. I think we have spoken about it. And there are offline log messages like website logs, and your logistic business. It has a storekeeping logs. So there could be different sources for this log. So this is just one pictorial representation of what I spoke until now. Like there are, the Facebooks, your Twitters, and your YouTube. Interestingly, on YouTube, you've got a lot of data. There could be millions of data that's stored in YouTube, and it's very interesting how this data is organized there. Just to give you a simple gist of what every hour Walmart experiences. Now imagine this kind of data, which is, if you're talking about a month's data or a quarter's data, it's unimaginable. I mean, it's very massive in volume. Interesting fact, one more example, a Boeing plane that generates 20 terabytes of data for every hour of flight. And assume if it's just flying from an Indian continent to subcontinent to an American destination, there's around 18 to 19 hours of flight journey. So we have 200 bytes, almost 400 bytes, I'm sorry, I beg your pardon. 400 terabytes of data that we are talking about. So this is just one such flight. And if you're trying to analyze the flight patterns across a year or across a month, so that's a massive volume of data we have got. Just a repetition of some of the items that I spoke. We have all these websites or these companies. They have billions of users, so they are like consumers of their products. So that also, since you have more consumers, more data, it's likely that you'll be getting more data out of it. So all these things, I mean, the torrent downloads, as we said, they keep a log or track of a user activity or a user profile or even a user database. So this is a massive volume of data that we are doing. And I know some of these organizations like Facebook and I believe Twitter, I don't know Facebook, but Twitter really exposes some of these data sets to the public forums, maybe through, and they have a lot of APIs also, software APIs, which you can use to gain the insights on their data sets. Facebook used to do it through commercial website, through a commercial API, but I heard in the recent past they have stopped doing it. So they also expose this data to the external world, I think for a good need. I'm sure they would also take care about the privacy part of the data set, but they do also expose these data sets to the prospective users. And I believe that's the hidden agenda we have got, right? I mean, today's world, everything is available on, at least on the Android devices. I know on Macs, which we use, I mean, it's commercial thing, but on Android, you name an app, you can just install it. But there is a breach of data that they are doing it. If you have noticed, when you install an app on your mobile device, especially on the Android app mobile devices, it says that, I want to access your messaging, I want to access your location, GPS locations, I want to access your internet profile or your blah blah blah, you name it. So I want to access your address book. So all this is done to get more data, because in today's world, data is gold mine. The more data you have, the more insights you can draw. To give you one more example on why I'm emphasizing that the more data you would need is, in the recent match, if you have seen the India versus Pakistan match that was recently concluded in last T20 World Cup, there was a very interesting stats we spoke about. One stat which says that India never lost a match against Pakistan in a World Cup. And there was another stat which said that Pakistan never lost a match against India in Eden Gardens. But the first stat was true, and we saw that India eventually won the match. The major reason for the stat one, which says that India never lost a match against Pakistan in World Cup, was because there were more data points compared to what India versus Pakistan match in Eden Garden. So there were like 4 or 5 matches which India and Pakistan played in Eden Gardens, but there are many instances where India met Pakistan in World Cup. So that's the volume of data we are speaking about. The more the volume you get, the more insights, the more accurate insights you can drop. So all these data hungry devices or data hungry apps, they want your data to 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 make some analytical insights to a certain product. For instance, you might be very often visiting a vegetarian restaurant in based on your GPS location. So that can give you that can suggest the prospective restaurants in your location, vegetarian restaurants, to send an advertisement to your Facebook page or to your Gmail account saying that, hey, I'm serving you a vegetarian meal in this location. You might be interested to explore this. So this is the kind of insight we're talking about based on the data that's available across the globe. Right. So all we know is getting data is not a problem. Not a problem, as we know that all these devices, you have web applications. So there's everyone who is generating the social media. They all are generating a lot of data. But the biggest challenge that we would inquire is once we have this data, we are to the tune of petabytes. I'm not even talking about zettabytes. I'm talking about data which is to the tune of petabytes. I'm not familiar about a server that can store 100 petabytes of data together in one server, one storage place. Okay, even if you find a server which is capable of storing it, how do you write a piece of software that can actually, iterate through this 10 petabytes of data and give me the insights that we just spoke about, and to process an insight? When I say insight, it's trying to analyze this data set. So that's the kind of challenge we're talking about. So storage, the process, and the analysis of this data. There are 3 areas which will be a challenge, and we'll see in next slides how this challenge is actually conquered. So what are different approaches, right, which market used to adopt, or which market traditionally how market used to do, or different businesses were doing to handle such kind of data? So first thing first, we used to design and implement a software that used to sequentially work on these data sets. Because it's not capable of handling all 10 petabytes of data, it used to say that I'll get 10,000 rows, or let's say a 1 GB of data, and I'll process it intermittently, and then I'll get another 1 GB of data or another 10,000 rows, and I'll process it. So there was a software written to work on in this sequential way. And as I was saying, where you would store this data. So if you are familiar with languages like Java or C, C++, we store this data into data structures like tree map, hash maps, or linked lists or lists. So we can, but imagine if I'm asking you to store a 10 petabyte of data into these data structures. That's quite unimaginable. I mean, you will not be able to store those data sets into these data structures. These data structures can never scale enough to store such data thing. And obviously our input and output data source used to be a SQL, like a relational database, or an XML output if you're working on a SOA architecture and you share your output with another platform. Right, so that's all we are here for, because the problem that's been solved by on this big data is through Hadoop and its distributed file system. Next slide will talk more on the distributed file system, the Hadoop ecosystem that we've got, and the architectures. So just to summarize what we spoke about, the challenge is we have a data which is in volume, which has a massive volume, which is generating at a constant rate, and which is very varied. So our softwares that we have written today, and even the traditional data warehouse softwares that we have in the market, are not capable enough to consume this data, process it, and give us the output or an outcome. And if you want to do it at a very constant rate, I'm sure these softwares would fail at a certain point. And also the storage engines that we have got today are not really scalable. I'm sure Oracle is coming up with such storage engine which is called distributed database. I'm really not sure if it's Oracle or Google, but yes, one of them is trying to bring up a distributed data storage database engines. But still, until then, we have a problem where we cannot store the entire set of data into one database or one server. So enough we talked about it. Now let's see how I mean, we just spoke about all this about the problem in conventional approach. We have seen how it has got. One interesting thing which I didn't spoke here is the unstructured data. Since you have written a software which is capable of, or which is designed to process a certain schema of the software, or a certain schema or a certain structure of the data, and if you feed this data, if you feed in a data which is not similar to what it is designed for, then your software is going to fail or your business logic is going to fail. So to do that, you obviously need certain cleansing or pre-processing to make this unstructured data or model it into a structure which your software is more aware about or more familiar with. So now let's get into Hadoop. Yes, this is the technology or framework right now we have in the market, which is very widely used on to solve the big data analytical needs and problem statements. So in the next few slides, we would be talking about a brief introduction on how Hadoop has evolved and what was the historically how Hadoop was really originated. And then what are the different advantages we have got when we compare to the traditional or conventional softwares or data warehouse tools that we have today. And how Hadoop is being used in the industry. We will also see certain frameworks, the internal Hadoop stack and the ecosystem. And also share you on the slide if you want to install an Hadoop on your machines, how it works. This is powered by Apache, an open source software foundation. Hadoop is now a top level project. It's been promoted. It was incubated certain time back. So obviously that gives him an advantage. Right. So let's get a little bit of intro about Hadoop. This is a very common term we are hearing in big data world. So I'm sure some of you would have already heard that there is something called Hadoop. What is it actually? So Hadoop is actually a framework which is meant to meant for distributed and parallel computing, and for a massive. And when I say parallel computing, it's a massive parallel processing. I know even in your software you can write multiple threads to do a parallel processing, but this framework is capable of doing a very massive parallel processing on a distributed data sets. So your data, and when I say a distributed data set, it is of the same variety, the 3V's nature it has got. And we would see in next slide, there are different, there are three architectures which primarily compose on Hadoop. So there is a programming software or a framework which it uses for this massive parallel processing. The biggest advantage with Hadoop is, as we in previous slides, the scalability was biggest challenge for us with conventional softwares. This Hadoop is very scalable, it's very configurable, and you can, it's very highly available. And it's highly available, there is no single point of failure. So when your job is in execution, the scalability is pretty easy. There are 100 or more than 150 configurations which I'm familiar with in Hadoop, which allows you to tweak your job or fine tune or introduce tunable knobs to different parameters of your job statistics. Likewise, it has a lot of other advantages. And the very good thing what they did, if you want to run an Hadoop cluster, you really don't need a very high-end server, or you don't need a blade which with 32 cores or with a 200 GB hard disk, or you just need a commodity hardware. For instance, I think we have few folks here on this webinar. We can all make our laptops or our devices as one cluster. So it can run on a commodity hardware. So when I say commodity hardware, you probably would say that, oh yeah, it's just a commodity hardware. What is the fault tolerance it has got? The framework is so beautifully designed that it is capable of doing a lot of high availability and storage security of your data. So we will see how it does in the next few slides. Okay, the guy on the left side, he is one of the core contributors or inventors of Hadoop, Douglas Cutting. So in the year 2005, the Hadoop was originally originated. I mean, this was a project called Lucene, and there was another project by Michael J. Caffarella called Nudge. So what Lucene was primarily meant for was to do it. It was a search engine which is based on indexing. So everything is indexed, kind of an inverted index, which we have, not the conventional indexing that we see in our relational world, but it works on a kind of inverted index, and it actually, the nudge kind of crawls the data from the web, different sources, and gives an insight to the Lucene, and inside the Lucene in turn picks up this data and indexes it and makes your searches a little faster. Now, what these guys, Douglas Cutting and Michael, what they did, they got a little inspired by Google Labs paper that was published in 2004, which was on MapReduce. We'll see what MapReduce is. It's just a functional programming for a parallel processing. So what they did is, if they start introducing or combine these attributes into their project, they can actually build a massive parallel processing platform that is capable of dealing with petabytes of data or a huge volume of data at short interval of time. So this guy moved into Yahoo in certain time, I think around 2006 or somewhere, and that's where Yahoo saw some gains in it. And finally, around 2006, Yahoo has contributed this project to open source and Apache Software Foundation ASF, and now it's a top level project and it's freely available. Though there are a lot of distributions available in the market, the core Apache's Hadoop still remains free and open source. You're free to use it. You're free for everything. I mean, it's fully available, freely available. But the commercial versions like Cloudera or Hortonworks, Mapr, they have certain restrictions, and they give you an additional features from the core Apache Hadoop. So there are three things which Hadoop does. The underlying file system. Unlike the conventional file systems, it has changed its file system, and the way it processes, and finally the tools that it gives to analyze your data. So the first thing, the storage, it's called Hadoop Distributed File System. Everything is distributed across different data nodes, and these data nodes, as I said, it can be a commodity hardware, it can be your high-end server, it can be a plain vanilla device. So these are the different set of nodes which combine together form a distributed file system. So this, what they do is called as clusters, and there are these different nodes are called as data nodes. So the idea is to distribute the data, distribute the processing capacity across these nodes, so that you do everything in parallel, and you, instead of solving or trying to work on one sequential data set, you're working in massive parallel processing sequence. So there's again no need for high-end hardware. As I said, you can get some basic CPUs with 4 GB RAM or whatever RAM you have got. So, but there's actually a catch here. I know in production environments which we work, we never use commodity hardwares because we really need some processing capabilities. But that's not the prerequisite, though. You can still use a commodity hardware. To process it, it uses map and reduce framework. We will see what it is in next slides. And the analytical part of it. So once you have processed it, how do you analyze this data? Because once you are into the Hadoop cluster, the data may change. Your input data, let's say, is from a relational world, and once after you process it, it changes its attributes. And it also, because it's just voluminous, you may not be able to take it back to your relational database to do an analysis on the processed and modeled data. To do that, it also gives you certain ecosystems like Hive, Pig, and Map. Both are actually built on top of MapReduce. So they are like, you can assume like Pig is a scripting language, and Hive is a more for the people who are more familiar with relationals, SQL-like statements. And Hive is from the Facebook. It again contributed to the open source project. It's freely available. Very interesting, the scalability part of the Hadoop cluster. I know people who are working on data centers would always say that, or maybe we have seen certain emails from our IT folks saying that, we're doing certain maintenance, we're upgrading our LANs, or we are upgrading our servers. So you will experience a downtime. That is because the traditional data centers are not meant for highly available. If you make any upgrades in your data center on your network topology, they require certain downtime. But unlike that, the Hadoop and HDFS, primarily the Hadoop distributed file system, is quite scalable. So today, let's say if you have some 2000 nodes and you want to just add one more node, or you want to decommission a node, you don't have to take your entire cluster down. You don't have to shut down your cluster. All you have to do is just plug in your node, and on the command line, or there are UI interfaces also available. You just there are actually some configuration XMLs which are available, through which you can specify or notify the cluster about this new node, or you can notify it that you're decommissioning this node. But that's not going to impact your cluster. Your cluster will be still online, and you can still continue using it for your processing and data ingestion. So that is one very good advantage. It is quite scalable with a very minimum, or I would say no downtime. Yes, the primary features of Hadoop distributed file system, it is really highly reliable. We would see next slide why it is, but just to give you a gist, the data that you store in your HD, in the HDFS or in the distributed file system is very reasonably replicated. So if one data node is off, or it is offline, or is decommissioned, you could still be able to retrieve it from the another replicated data node, or a node from where the copy was maintained. And it's a distributed architecture, so where your entire cluster is not managed, or is not under one zone or under one server. It is actually fully distributed. You have tons of data nodes which are equally processing, or which are equally sharing the data available across the cluster. And we spoke about scalability in next previous slides. This is what I meant by replication. It stores on multiple copies of your data, because based on the replication factor that we set. The idea behind, if you see in, so how does it actually achieve? I mean, you would be curious to know that when I say your data is distributed across the nodes, or different data nodes. The first thing first, what it does is, the moment you try to ingest a file into the cluster, onto the HDFS, it breaks them into chunks of data. So the chunks of data is called the blocks. So for a granularity, you can assume that you got a 1 GB of data. So when I say 1 GB, and let's say you have a predefined limit of block of 64 MB. So it just breaks these data sets into 64 MB blocks, or it is actually configurable, by the way. So when I say about blocks, these blocks are configurable. So you can configure the size of the block. So whatever configurations you have specified, it breaks the data into these chunks of data, that is nothing but blocks. And each block, it actually distributes across different nodes. So a file which is of, let's say 1 GB, or to be little fair, and let's say we have a 100 MB file, and we want to store it into the HDFS, and each block size is defined with 64 MB space. So all it does is it breaks the 100 MB file into 64 MB plus 36 MB, 2 blocks, and each block it stores into a different data node. Plus, what I said is the replication factor that we spoke about, the multiple copies. So it also replicates these blocks into different data nodes based on whatever replication factor we have specified. Typically, in the Hadoop Apache distribution, the name node is single. So yeah, I mean that's one master which is actually managing the different data nodes to form the HDFS cluster. So since it is a single name node, it has a single point of failure. But in the commercial environments, and typically people don't use core Apache Hadoop. They use Cloudera, Hortonworks, or Mapper. There, these name nodes are sufficiently backed up. So you have a backup name node, which actually can act as a backup to your primary name node. So if you see this picture, before we moved into DFS, the data was stored across different servers. That's what we were saying in my previous presentations or slides, that typically you would store your data into one server. Let's say the home directories are stored on the Chicago Disco server, reports are stored on Houston server, and your actual software is stored under Denver server, and your main project is under Chicago Maxi. So Once you move this data into HDFS, for the end user, it is actually, though this data is now stored across different data nodes, but it appears for the end user as one entry point. So you can just say, I want to see the data which is stored in home directories. It just gives you back the results because everything is under one name node, but though it is distributed across different data nodes. So the name node actually tells you back or gives you back the feedback or the result of your directories. So a typical name node, data node architecture in production environments. As I said, there are two data nodes. There are two name nodes. I beg your pardon, which is managing three data nodes together. So the moment the data is ingested, it talks to the name node. The name node in turn, before even the data is ingested, let's say that you're booting your cluster. So let's say this is one such cluster, and you got one more cluster. There are two clusters, two different distinct clusters. And once you boot your cluster, the first thing what it does is that each data node sends a heartbeat to the name node, giving different health state informations to it. For example, the amount of disk space it has got, the amount of processing capabilities it has got, and is it executing any tasks at this moment, and what are the blocks it has stored. So there are other details which it sends to a name node, and name node actually keeps a track of all these data nodes. So if I say that I want to see where is my reports stored, so name nodes identifies blocks associated to reports. Let's say the block is stored in this name data node and this data node, and it actually clubs them together, and it first tries to find the file to block mapping, and from the block mapping it gets the file name and it sends us back. So it's a typical master slave architecture where these data nodes, they keep sending their periodic heartbeats to the name node, and the name node keeps a distinct data set information about the state of the data node, if the replication factors, and in case if certain data node is down, how it can move, it just went down or it is decommissioned. So it has to move all this data to the next available or healthy data nodes in a rack. So those are the other activities it does. So name node is a master, and the data nodes are the slaves, which keeps talking to the name node all the while. That was HDFS we spoke about. We also have job trackers and task trackers. Primarily, these are again processes. So if you see one node, there can be three instances: a name node, a job tracker, a task tracker, and four instances. Data node. I beg your pardon. There are four instances. So in a master node, there could be four instances running. One process could be a name node, another process could be a job tracker, and a third one would be a task tracker, and fourth one would be a data node. In a data node or a slave node, there could be two processes, one namely task tracker, another one would be a data node. So these are the processes which run in a data node and a name node, a master node, which we are saying in this slide. And all of them, they run in their own JVM instances. Most of the Hadoop is designed in Java, and they are only capable of running on Linux. But there are other, like Microsoft, I believe, was some time ago was trying to implement a similar architecture in Windows. But primarily in production and many market businesses, they use Linux-based platforms to run these Hadoop software. Most of the software is written in Java. But having said that, if you're not from a Java platform, don't worry too much, because there are other APIs like Hive and Pig, and now you have Storm, Scala. They all are fairly written in a very fairly simple language, and they just abstract the Java part of it. The ecosystem, yes. So we've got a lot of tools, processes built around in Hadoop. So we have this basic storage engine, which is HDFS, the Hadoop distributed file system, and then we have the MapReduce, which is for your primarily meant for MapReduce for your querying or your doing some sampling of the data. And then we have the Hadoop database, which is a NoSQL database meant for again storing large data sets with no SQL or with no schema association to it. And two very interesting processes, the zookeeper and Uzi. The zookeeper is like a coordinator which keeps a track of where is your data node, where is your name node. For instance, if I want to say, if I want to query a file, the first thing that I hit is zookeeper. If it is configured, again, it's optional. It tells me that, where is my different blocks are there, where is my name node is there, first of all, and what are the map reduce jobs the data nodes are executing. So likewise, even in if I want to query some HBase table, the first thing I hit is zookeeper, and that tells me that where is my HBase instance, the master server. Even HBase is a master slave architecture, so where is my H master executing, how do I locate it, what are the coordinates to it. So there is a quorum which it maintains, which is primarily meant for the coordination between all these processes that are running on the cluster. Uzi is meant to automate your job execution process, like your map reduce. If you want to run a map reduce job, if you want to automate the run flows, or if you want to schedule how often you want to run. So it is a workflow and scheduling system for basically meant for your organizing or running your jobs. There are many such ecosystems available. There are many such more things coming up every day, but these are the ones which we widely use. Keep looking for those blogs. You would be seeing what are the latest ecosystem tools we are getting in. Again, to revisit what I said in my previous slides, it's a completely distributed architecture where when you say HDFS, it's fully distributed, but it is managed by the name node as central system. But in most of the commercial tools right now, we have the commercial distributions. It's not centralized. There are backup name nodes also available, but it's just a master slave architecture again. Master node, where most of the computational and power and storage of the file system lies, may not be very true with all the cases, but it's a choice that a Hadoop administrator makes. Among all the available nodes or machines that you've got, which one is more? Because it's obvious that this guy needs more processing power, because everything first hits the name node and then it gets into the other nodes. So master node is, yes, obviously a parental node through which you manage or you access the data nodes or job task trackers. So the job tracker and task trackers, for example, when I say map reduce job, it runs into, it has two jobs basically, map job and a reduce job. We'll see what is that in next slide. For now, let's assume there are two tasks that it has to run, the map task and reduce task, and those tasks are run on your data nodes. The reason why they run on the data nodes is it's obvious that your blocks are stored in your data nodes. So you would need these tasks running on those data nodes. So the job tracker, first thing, it actually manages all these tasks through the task trackers, and it also distributes or allocates these tasks to the available task nodes or a data node. The one advantage with this framework is it's quite intelligent enough. When I say a block, and if you have a very huge data center, and if I store one block on the first data node and another block 10 hops away from this first data node, so obviously the processing capabilities would be compromised, because if I'm trying to run a job on these two blocks which are associated, so what I need to do is I need to run the job on first data node. Again, I hop through those 10 another data nodes and get into this block and run it. So what HDFS does is it's very intelligent enough. It has a rack awareness. It has a data locality awareness. So it tries to keep your data locally into the same rack, or as closely associated, as closely as possible to the two given data nodes. So there is a rack awareness, there is a high availability of HDFS, and there is also the data locality, or how HDFS handles it, or the framework handles it. Primarily, as I said, the whole Hadoop is written in Java, and it also has a support for scripting languages like Ruby and Python, and you can inscript like shell scripts also you can write for using streaming APIs. So it's a master slave node architecture we have seen. Let's actually see what a name node, the thing which I said here is a master node, looks like. The first responsibility of it is to, the moment you ingest a file, it gets broken into blocks and gets stored into data nodes. So it has a it actually stores a metadata info about your file to blocks, blocks to data node. So that mapping. So if I'm going to query a file, or if I'm going to say ask the name node that tell me the file called report underscore one, where it is, and just keep of it. So first thing it does is it scans through a metadata file called fs image. It's a flat file which is only understood by name node. So it contains this mapping called file to blocks, blocks to your directory, blocks to your data node mapping, and it returns me that mapping and it gives me the entire file. So name node is a little crucial, as I said, but most of the commercial distributors, they don't have only single name nodes. They have a backup name node, but it is still crucial because you have one guy who is actually telling you or who's giving you an insight about your entire cluster. So it's important to keep this guy safe and healthy always. So high availability of data is achieved through replication factors, and replication factor is configurable. You can keep your data you can replicate your data to any number, and it just keeps those copies. So, but the thumb rule is ideally what administrators do is based on number of data nodes available, they set the replication factor. Otherwise, the data gets replicated in the own data node, which doesn't serve your actual purpose. And once you submit your MapReduce jobs, it also executes your task on the data nodes for your job execution. Now, data node, that's the guy who's actually doing all your processing, the data storage, and the other aspects of it. So the first thing is it's a node which actually sends a very periodic heartbeats to the master node, telling the status of its file system, the storage capacity, what tasks it is executing, and all other such details. So it sends a very periodic heartbeat, and it stores those blocks of data. And there is no hard and fast rule to have a file system like like you only need to have an NTFS FAT32 or anything. It can work on any node. As I said, it's just a commodity hardware. You can plug in into your cluster and make it as a data node with a minimal configuration, specifying where is your name node, where is your other task trackers running, where is your job tracker, on which port your job tracker is running. So with the minimum configurations, you can even use a commodity hardware. There's no hard and fast rule on the file system. Also, it can store your replicated blocks based on whatever replication factor is set. The default application is 2, I believe. So most likely it tries to keep everything in local in the rack, and the other, let's say if it's replicated for 3 replication factor as 3, it keeps another block above beyond your local rack. The reason is if your rack goes down, it can still retrieve the data from another rack, just as a precautionary measure. Okay, very complex diagram, but let's try to break it down so that you guys can understand. Let's say you have one file which is broken into blocks. This is your input file which is broken into blocks. Before you feed it into your MapReduce, into your MapReduce job, what it basically does is, so if you really try to understand MapReduce, right, it is just a functional programming model which is meant for processing massive volumes of data sets with parallel and distributed algorithm. The reason I'm saying it's capable of processing massive volumes of data set is these blocks are spread across different data nodes, and all these blocks are executed, or they execute your job in parallel processing way. So it is distributed and it can work on massive volumes, because now assume this is your file, an input file which is broken into blocks and stored in HDFS. Once you submit your MapReduce program, MapReduce is again written in Java. The core MapReduce is written in Java, but there are wrappers like Hive and Peg. They have their own wrappers built around. They don't use Java, but underlying they still invoke a MapReduce job. So there are 3 phases to your map. A map job where you write your actual business logic, the way we were saying that in conventional softwares which have the business logic embedded. So that business logic is written in your map job. This is your map job, which takes an input. Your input block is again broken into splits. The reason why it is broken into split is to have a logical partition of your block. for example, I have 100 lines in one input split, but logically it should be broken at 90th line, 90, because that's where my logical block ends. So it tries to create your splits, and these splits are again fed to your map job. Now this map job is the actual job where you have written your business logic to produce the output. So it takes an input and it actually produces output. So everything is in a key value pair form. So the input should be in a key value, output should be in a key value form. So at the end of your map execution, it will produce different sets of key values pair, key values. So what it does is it can either combine similar type of keys in your map phase, or it can leave it to a shuffle sort phase and ask the reducer to aggregate all values of similar keys into another key value pairs. So you got an input file. So if you see the way we are saying that this is a file which is of size 1 petabyte, and we have broken them into blocks, and these blocks are fed into map and reduce jobs, and there are hundreds of such map reduce jobs running on different data nodes across the cluster. All they are executing is your business logic. They're taking your input splits, they're producing the outputs as a key value pair, and your final reducer is actually combining all those similar type of key values into and giving you a final key value pair. So we have seen the advantage with this programming model is it works across distributed data nodes. It can handle massive volumes because the data is spread across different data nodes, and it can easily scale. So the map and reduce remains same. You can write your own logics, embed your same software logic, that business logic that you've written in your conventional software into your map job, and you can also use a reducer to combine your final outputs or aggregate your final outputs. Let's take an example to understand it very well. This is my input file split or input. Let's assume this is my input file which contains these texts: DVD, Blu-ray, CD, DVD, CD, video, Blu-ray, DVD. And what I'm trying to see is I want to try, my business logic is to understand how many occurrences of DVD, how many occurrences of CD I find in each line or each input split. So I write that business logic here, which says that if I take the first input split, which got DVD and Blu-ray, I say my key value pair is Blu-ray is the key, value is the number of times that Blu-ray has occurred, the instances that it has occurred in this line. So it is 1. Similarly, DVD is 1. So at the end of this map execution, the first map task execution, it gives me an output like 2 key value pairs. First key value is Blu-ray, 1, and another key value is DVD, 1. Similarly, the second input is also fed into this map task, and I get the output as CD, 1, DVD, 1, because I only have 1 instance. So likewise, if each instance I'm trying to find out, and each map task is working on distinct input splits, so it goes through a shuffle sort phase, which keeps similar key values into 1, and finally it aggregates the data. So by end of this reduce phase, I have almost 4 key value pairs. First key value says that there are 2 occurrences of Blu-ray in this entire input split. There were 5 occurrences of CD in this entire input split, and there were 3 occurrences of DVD and 1 occurrence of video, the word video. So the map, if you've seen, if you go back to your conventional softwares, how it would have worked is, now this is just a fairly simple 5-row data set, but let's say it is a 50 million data set, and I'm trying to find out a similar occurrences of how many occurrences I have with the name called Blu-ray. So that conventional software it would do is, assuming that this is stored in a relational database, it makes a connection to the relational database, iterates through each row, and keeps a counter. So the same logic that I have written in this map, I would have written in an object-oriented or a functional program, which will go through each row, keep a counter, increment the counter as soon as it occurs. So it might take a day for it to complete the complete iterations, but what I did here is, since I've broken this data into different input splits, now the same job or the same piece of business logic I'm executing on each row in a parallel distributed fashion. So that actually kind of interleaving the time slots or time slices, and I'm getting more data out of it, or I'm actually improving the performance by parallel execution. right? So this is one of the key attributes of Hadoop. It's highly reliable because of the replication factors, and the data nodes are very easily replicated. It's flexible. The reason why it is flexible, and I would say it's flexible and scalable, is it's very easy to configure. You have predefined configuration set of XMLs available, and you can plug in any hardware into your cluster. There is no hard and fast rule that you always your all data nodes should be of a similar configurations or similar capabilities. But in production environments, again, they keep a consistency just to ensure, because if you go back to this slide, I have 3 maps running. Assume this is running on a commodity hardware, and this is running on a high-end HP server, and this is running on a Solaris box. So my first guy who is running on a commodity hardware will take a little longer to complete. So I'm essentially not achieving the full-blown parallel processing capacities. So this guy may go into a speculative execution compared to other guys, because he will finish later than the second and third guy. But again, there's no hard and fast rule. You can still use commodity hardwares. You can still easily plug and play. You can remove, decommission. You can add your different data nodes at any point without taking your cluster down. So it's very economical because it is built. The basic principle was to use, make it available or implement installable on commodity hardwares. But there are certain drawbacks. If you go back to the previous slides, what we were doing is we ingested this data into HDFS. And then HDFS has broken this data into blocks, and then we ran the map reduce map job, and then reduce job, and then we got the output. Everything is actually sequential and batch oriented. So I do a set of batch commands which says that ingest the data, run the map job, run the shuffle and sort phase, and then run the reduce phase, and then I get it. So it's a batch processing that we are seeing. So, but now it is actually evolving. It's not really true that it will always remain as a batch processing. There are Scala and Storm, new APIs being built, which are event driven. So you can also do a near real time analytics on this kind of data sets. So it's actually a partially true statement that it is into a batch and offline processing mode, but it is now capable of even doing real time analytics, near real time, not like complete real time, near real time analytics. And remember, it's not a database. It is just a storage space which does the processing or computing through map reduce jobs. So there are no such things available. I mean, it cannot be. But Hadoop database is not the HBase that we saw in one of the slides is not the storage engine. It is just a NoSQL storage space, which has a different technique to solve or install your data into it. This is few steps you can. I'm not sure if it really helps you to go through it, but if you're really interested to use Hadoop, the basic underlying operating system is Linux for it. Yeah, most of the distributions that we have, you name it, whether it's Cloudera or Apache Hadoop or Hortonworks, they are all built on Linux or Unix platforms. And you would also require the Java runtime environments to run it, and some of the basic shell scripts. But don't worry if you don't have a Linux server or you don't have a Linux box. There are a lot of virtual machines available online. There is an Oracle virtual box. There is one from VMware freely available. So you download those virtual machines, and as I said, you need an operating system. So you obviously need to download a Linux box or a Linux virtual machine, which is available. Like Ubuntu is one we have shown here, but again, you can download a Red Hat Linux or CentOS also. Once you have done that, you would need Java as well. So you need to install the Java development kit. Right now, OpenJDK is also almost aligned to the OpenJDK from OCI is also aligned with the Oracle's Java. So you can use either of them. Since it's freely available, you can download OpenJDK 6 or more. Remember, it only works beyond 6, Java 6. So all you have to do is download the distribution, Apache Core distribution. So which is like it's available here. You can download it from the websites, Google website or Apache archive.apache.org. the latest distribution would be better to download. Once you enter it, these are certain steps which you can just listed in README to install it. But if you are not willing to use core Apache Hadoop, I think even Cloudera gives you a free trial versions, Cloudera Hadoop, Hortonworks also. So they are actually pre-configured. You really don't have to configure your cluster. You don't have to configure your name node, data node, or your HDFS side XMLs or map side XMLs. They are pre-configured. So Cloudera also has a virtual machine image available on their website. It's pretty huge though. I think it's in few GBs. I think about 10 GB. But that's fairly easy to use, and you really don't have to do it. But if you still want to stick to your core Hadoop, core Apache Hadoop, then you download a VirtualBox, Oracle VirtualBox, or a VMware VirtualBox, virtual machine, and then download an image, Linux image, and plus the Apache distribution. So these are the steps. So all right, that's all I have for now today. If you have any questions, you can go ahead and ask me. I will be glad to help you or answer your questions. So the floor is now open for your questions, guys. Go ahead. You can unmute your lines or you can type it on your chat window. I'll be able to take your questions either way. So any questions or any doubts you want to ask me on all the topics that we have shared today? All right, then, if you have no questions, we can hang up the call. Thanks again for your time in joining this webinar. Really appreciate it. I hope you understood or learned a few basic things about big data, Hadoop, and what are the latest use cases that are available in the market. So, okay, so there's a question which says that how does a business analyst fit into this profile apart from technical aspect? Okay, the question is someone is trying to understand how would a business analyst really help? Okay, now if you are from a business analyst profile and you want to draw a data insight from it. So unless now, there is a very thin line. If you have heard, there is a term called data scientist. So which are very interchangeably used with business analyst. So what a business analyst can do is he understands your business or your operational data very well. So the business analyst who understands your operational data very well, when I give him or her a larger data set and I ask him or her to draw an insight and tell me that what would be my product profile in next few years or few months. So until now, if you are a business analyst who is only dealing with your operational data, when I say an operational data, it's a day-to-day data. You might find little challenges because the kind of tools that you have right now may not really help you to do it. So if you are a business analyst, obviously the advantage for you is you really understand the product profile or your solution very well. Now, to take it to the next level, and if I ask you to apply your same understanding and your same skills, you might find it challenging using your existing, let's say if you're more familiar using your Excel sheets to draw certain insights, and if I ask you to go beyond that and tell me how would you predict my product profile. So that's where it helps you if you get into this world of big data analytics, because you have an advantage of game and you also have an advantage of business understanding. But if you're familiar with tools like Hive or Pig, so you can apply the same skills or tools. Let's say you were trying to do some operational report analysis based on past 6 months. So you can apply the same queries on Hive and you can find more, you get more insights. So this is actually helping you. The big data analytics is platform is helping you to realize or release those, reuse your existing skills on a bigger platform. Definitely, business analyst can also turn into a data scientist because there's always an added advantage for you of understanding your product profile and market very well. So uh, each role has its own way. As I said, data engineers might be a little more in demand. Okay, there was again one more question. I think you're looking for which one would be more better, Hortonworks or Cloudera or Apache Hadoop. So, see, if you are a newbie, I would recommend using Apache Hadoop because that helps you. Cloudera. If you're using a Cloudera, you obviously would not know the basics very well because you really don't know. If you get into a problem, you don't know which site.xml to configure, where to configure your class paths. So I would recommend using Apache Hadoop from scratch if you are a newbie, but in production environments, no. It's no from me, for me at least. You cannot, or you should not use Apache Hadoop if you are fairly dealing with petabytes of data, because these guys like Cloudera and Hortonworks, they do a lot of pre-configuration, scalability test. See, when you're taking up a free open source software, right, there's always a little doubt in your mind about the what do you say, the scalability, not scalability, but the reliability of the software, because it would have been never tested against a massive volume of data. So I would recommend going for either Cloudera or Hortonworks. Cloudera has a little better advantage than Hortonworks because of the various tools that it offers, the online, the web-based tools. So the user experience is good. They have some web online tool called Hadoop user experience, which consolidates all Hadoop related data into one UI and give it. So if you're asking for a production environment, I would definitely recommend go for Cloudera or Hortonworks. But if you're trying to understand, if you're a newbie and if you're setting up a pseudo node cluster, you go with Apache Hadoop, and that would help you to understand it from scratch. Hope that answers your question. I'm sure, yes, the PPT, I don't know how this would be shared. Maybe someone from our team, Techcanvass, can get in touch with you. I'm really not sure if we can share it, but yeah, I mean, if it is allowed to share or if it's available to for your access, I'll be uploading this presentation as well. Yeah, any other questions we have? All right, guys, if you have no more questions, time to hang up. Again, thanks for sparing your time on a Sunday morning. I hope you would have understood some of the basic things about presentations, which I tried to my best to explain. Once again, thanks for your time. We will then wind up. See you and bye-bye.